Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. We're going to continue talking about assembly level programming, and we're going to use Visual Studio. Specifically, we're going to use the inline program ability that's built into our C++ programs. So what I'll do is I'll just simply create a new project. And I think I've already given to you assembly language lab 1, lab 2. Let me go ahead and make a lab 3 here. And so once again, I'm just selecting a C++ program, Win32 console application. Let me just switch back over here really fast. I want to see what I did in terms of, yeah, so I just said assembly language 2. Do I see the name up here? This one says assembly lab 2. Okay, so I'll make this assembly lab 3. So I'm going to call this CS242 assembly lab 03. Next, this is going to be an empty project, of course. And what I can do is I can go ahead and, within the source files, add a new item. And of course, that new item is going to be a C++ file. That's fine. I'm going to be just simply creating an inline assembly program. So everything is the same as what we've done in the past for C++ programs. So that means that I'm going to include IOStream. I'm also going to write down namespace, std for the standard library, int main, and then at the very bottom, I like to use a system pause, even though a lot of computer scientists get mad at me for doing this. This is not making my program portable. This is making my program only usable on the Windows operating system. So as long as you understand that, you can use that. This is only going to run on Windows, because Windows is the only thing that understands this idea of system. I have system pause, system CLS for clearing the screen. There's all kinds of system code that I can use. So this is only on the Windows operating system. If you were running this, you wanted this to run on multiple operating systems, then you would get rid of this, right? But it's okay to use it. Here's what I want to do. I want to ask the user to enter a number, and then I want to say that number times itself equals, and then whatever that result happens to be. So what I'll do is I'll just simply have the user enter a number, and then I want to determine what that result is going to be. So I'm going to ask the user to enter an integer, and then of course I'm going to obtain that integer with the cin statement. I'll put that directly into user num. Alright, so at this point, I'm ready now to begin typing the assembly language portion of my program. So it's __ASM. This is called inline assembly language programming. You are using an assembly language program inside of your C++ program. But all of the code is still the same, all the mnemonics, right? So words like MOV, move, right? Words like ADD or SUB, we call those mnemonics. Mnemonics are simply those letters that make something happen in the assembly language world. All right, so the first thing that I'm going to do is I'm going to talk to you about creating labels. So if I did something like this, if I said my sub colon, this is a label because it's followed up with a colon, enter. Now what do I want to do in this chunk of code? This is almost like functions. Right? This is a chunk of code, and we begin that where this label exists. So what I want to do is I want to move into the EAX register whatever user num is. That's the first thing that I want to do. Next, remember we talked about this idea of multiplying. So that's how I multiply numbers. Now I, in the beginning, means that we're doing integer multiplication. So what I'm going to do is I'm going to take EAX, and what that does is it multiplies EAX times itself, and it puts the answer in EAX. Right? Remember, EAX is nothing more than a location. It's as if I said, hey, what's your address? And you would give me a number and a street. Well, that's all this is. This is a specific address location of a register. It happens to be called EAX, which holds a 64-bit number. And the way that multiplication works is it says, put into EAX, or multiply rather, this times whatever is in EAX, and then put it right back into itself. All right, so now that that has the location, I'm going to MOV, I'm going to move into the variable result, whatever is inside of the EAX register. Well, you see over here, I created result. It's an integer. It's going to take the product of this that's stored here, and it's going to move it into the result variable. Okay, then I'm going to type in RET. Now this is an abbreviation for the word return. So in other words, we are going to return back to whoever called me. Well, who called me? Okay, now let's go ahead and do that part. Let me place my cursor over here, hit enter a couple of times, and I'm going to use the word call my sub. So the way it works out is like this. We enter into the assembly language program. This means jump to or go to. So from here, I would go to here. I would execute all the code. This means go back to whoever called me. Well, I would go back over here and execute the next line underneath it. Okay? So this seems kind of like recursive, where this is calling this and this is calling this. It just keeps on going on and on and on. So I better make sure that I jump out of the program. So what I'm going to do is I'm going to create another label over here called quit. Here's a label called quit. By the way, sometimes this happens where tabs are automatically inserted, so I just got to remove those tabs. And then over here, I'm going to say this, jump to quit. Now, this is an unconditional jumping statement, JMP. It will unconditionally jump to this location. So listen to that word, conditional. You know what conditional means? There's a condition. In this case, this does not require a condition. But I will show you different types of jumping statements, like JE, jump if equal to this, jump if less than this, jump if greater than this. Right? We have all kinds of jumping statements. This one just says, I don't care about that, any of those conditions. When you get to me, jump to quit. All right, well, what's after quit? Nothing, so end of program. So let me flow through this so you can understand how this works out. All right, I enter into the assembly language program. I jump, or I call rather, this subroutine. So I go to the subroutine, I execute these lines of code. Once I'm done, it says return back to whoever called me. So I return back and I go over here. What's after this statement? Because that's the one I'm going to execute. Well, in this case, it just says jump to the label quit. So I jump to the label quit. There's nothing else over here. We're done. So then it would execute the next line after this. So this is going to be my ASM, right? That's the ending braces for this guy over here. All right, so that's the end of ASM. It's the end of my assembly program. And then I'll just simply say cout the user number times the user number equals, and then whatever the result is. Because remember, the result, we established that. The result is the product of the two numbers, or of the number that was entered by the user. So in essence, we're just multiplying the number times itself. Let me run the program and see how this works out. So I'm going to put the number 5, enter an integer, 5. 5 times 5 equals 25. Yeah, that's correct. That's what we expect to happen. Let's stop the program right here and see how that works out. So I'm going to run the program again. I enter the number 5. I press enter. Okay, so as you can see, now sometimes you get these diagnostic tools. I just minimize those, and I don't need the call stack, and I don't really need the solution explorer right here. For the autos panel, I usually like to have this over here and not so wide. So this shows me all the values here. It looks like I'm going to call sub. So I have these tools over here of step into, step over, step out. So if I say step into, notice that I'm stepping into my sub. And I am about to execute this. Now, one of the modules that I like to have is, I like to see what, in debug and then in Windows, I like to see what's in my registers. So you'll notice over here, I have registers. So I'm going to click on registers. And so that tells me what's inside of those various registers. What's in the EDAX register, the EBX, ECX. And then if I wanted to, I could right-click and I could activate flags and I could see the state of the flags based on every one of these procedures. Okay, so what we are about to do is take usernum, which as you see is 5. We are about to move it into EAX. Notice that EAX has, who knows, some random value in there, right? So now I step over. Okay, we've just executed this line, so now notice that the EAX register has the number 5, right? Now what I'm about to do is I'm about to take EAX and multiply it times EAX and put the answer into EAX. All right, so 5 times 5 is 25, and you may be saying, well, hey, how come it comes up 19? Well, remember, this is hexadecimal, right? So let me open up my calculator over here. I think I have, let's see here. Okay, maybe this is not the calculator I was thinking. I think I was thinking about calculator in Windows. So calculate, up there it is. I think there's a programmer's version of this. Let's see here, view, whoops, not this one. Is it this guy right here? Yeah, here it is, programmers. Okay, so if I enter the number 25, you see there in hexadecimal, it's represented as a 19. And that's exactly what you see over here, 19. So this is the hexadecimal version of a decimal number 25. Okay. I bet you guys wish you had this on week 1 we were doing hexadecimal to decimal conversion. Why do you think I didn't tell you about this, right? Then the exam would have been an A for everybody. No, I'm just kidding. All right. So now we've multiplied the number, we placed that into EAX. What we are about to do now is to take EAX and move it into the variable called result. Now result, as you can see, is some random number. Let's go ahead and execute this by stepping over. Now result is 25. When I click return, so let's see what happens. I go back to the statement after my call. So I called this, and so over here it says jump to quit. All right, so we're going to step. Okay, we jump to quit. There's nothing after that. So we just simply perform the next statement, which is that cout statement. So I'll just continue so that you can see 5 times 5 is 25. So that is how you can think about functions in assembly. You create labels to do some code. And then if you want to return back to whoever called you, use RET, it goes back over here. Inevitably, what you want to do is you want to create a quit comment with nothing after that, because when you're all done, you just simply jump unconditionally to quit. Yeah, question?
So you have to call myself for it to be executed?
I have to call this to be executed in this context. Now, watch what I'm going to do. I'm going to take these and I'm going to delete it. Do I have to call my sub? No. What would happen is it would execute this, 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 it would execute this, and then that's it. It would run. So why don't we try it out? Let's see what happens. So I'm going to run the program. I'm going to enter the number 5, press enter, enter an integer, and there it goes. Okay, so we're breaking. Let's see what happened here. Let me see. Let me go back over here. Where was the problem? Okay, so I'm entering this, and I'm not sure why it's giving me an error, because all I did was call this my sub, and then I took away the jump statement. I'm going to ask the user for a number, user num. Yeah, everything should work out here. Let me do this. I'm going to take this away. Actually, let me take all these away. I don't think I have to worry about that label. Well, oh, that's why. Yeah, good eye. I'm returning to something that I've never called. Yeah, very good. Good eye. So let me take this away. RET. And I'll take these away too. Delete. So now I'm just doing this. Okay, the program should work now. Good eye. So let's see what happens when I enter 5. Yeah, there it is. 5 times 5 is equal to 25. So to answer your question, let me undo first of all and undo it. I don't have to call something when giving it a label. As you can see, it just ran through. But if I'm using this idea of kind of like calling functions, like I want this chunk of code to run first, then this chunk of code to run second, then you would want to do this. I could, yeah. You got to be careful because you don't want to lead to what's referred to as spaghetti code. You know, but the idea is you start from the top and you work your way down. So I'm really doing this, which is really executing this. Then I'm going to do this, and then I'm going to do this, and so forth and so on. Finally, when I'm all done, jump to quit. This is the strategy that you use for quitting your programs. Okay. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.